Bright QT. Every student matters.
Hello dear students, today we will be just studying about the combination of resistances. Combination of resistances. We have studied till now what exactly is resistance and resistivity. Now in a circuit we represent a resistor like a zigzag line. This is a variable resistance. The value of this resistance may be any. It may be 1 ohm or 2 ohm or 3 ohm or 5 ohm, whatever, right. Now we will be combining various resistances to get the desired total resistance. Why? We will study in a bit detail a bit later on. There are two possible ways by which we can combine the resistances. One is a series combination and the another is a parallel combination. Try to relate, students, what exactly is series or parallel combination. Let us take an example that this is our first resistances. Let us give it a name. This is R1, right, and there is second resistance. Let us give it a name R2, and there is a third resistance. Let us give it a name R3. Fine. Now this resistance has a value, whatever, 1, 2 or 5 ohms, 3 ohms, anything. This also has a value and this also has a value, and they may be same or may be different. Now if I want to combine these resistances, there are two options that we take. First option, as we have mentioned here, is series combination. Now what is meant by series combination is that we will join or combine these resistances just in continuation. For example, this is our first resistance R1. Just in continuation I have connected the second resistance R2, and in continuation again I have joined the third resistance, that is R3. This is known as a series combination. Fine. And this combination is further connected to a cell. This is the positive terminal, this is the negative terminal, and we have a plug-in key. We'll just switch it on. The current will flow through this, and we have an ammeter attached to measure the current. Got it? The ammeter will be attached like this, plus minus, because the current is coming over here from plus to minus, right. This ammeter can be attached here also, anywhere we want, anywhere we can attach ammeter. So this is a ray diagram or a circuit diagram to show the resistances connected in series. Fine. Now there is one more option, that we connect these resistances like this. This was the first resistance R1. I'll connect this resistance in parallel to the first resistance, and another resistance is also connected in parallel. So this was the R1, this is the R2, and this is the R3 combinations, and this is how I can connect them once again to a cell or a battery with the plug key and the ammeter. The plug key is on, I have switched it on, it is plugged in, so therefore the current will flow like this. I need to show the directions of the current using the arrows. So this is a parallel combination of resistances. Fine. Now there is a lot of difference between these series combination and these parallel combinations that we are going to study bit in detail. Try to relate it, please. First of all, I will be talking about series combination. This was the series combination that I had taken. Let us reconsider it. This is a series combination. Now this is the basic concept that I am telling you, so please try to relate it properly and thoroughly, right? This is the cell, the switch is plugged on, therefore, I will show the direction of current going from the positive terminal to the negative terminal, and this is the ammeter being attached, which will show us the amount of current. Now, this is our first resistance R1, this is our second resistance namely R2, and this is our third resistance R3. Now, students, try to relate please. This is a cell, or I can take a battery over here. This battery is the device which will maintain the potential difference in the circuit. So, we say that this battery is providing a total potential difference of the circuit as V. So, if I am talking about V, I am talking about total potential difference in the circuit. Fine. The amount of current which is flowing is the total, let it be I. So, I is the total current which is flowing in this particular circuit, right. Now, when the current is going to flow in this circuit, current is flow of electrons. This current will flow through this R1 resistance. So, let be the current in this first resistance flowing is I1. This is the individual current which is flowing in the individual resistance R1. Then some current is also going to flow through R2, let it be I2, and current is going to flow through R3 because they are connected, let it be I3. So, R1, R2 and R3 are our resistances, individual resistances. I1, I2 and I3 are the amount of currents flowing through these individual resistances respectively. Means I1 is flowing through R1, I2 is flowing through R2, I3 is flowing through R3, right. Now, across these resistances, this was the resistance, let us take, this is basically a resistance AB, this was the resistance CD, and this is the resistance EF. Across this resistance A and B, these two terminals, there will be a potential difference. Let that potential difference be denoted with V1 across the first resistance. Let the potential difference across the two ends of second resistance be V2, and across the two ends of the third resistance be V3. Now, I have got yet another thing, that is the individual potential differences between these three resistances. So, in totality, if I see that R1, R2 and R3 were three individual resistances. I1 was the current flowing in the first resistance, I2 in the second and I3 in the third. V1 was the potential difference across the first resistance, V2 across the second and V3 across the third, right. In totality, if I am talking about the whole circuit, then total potential difference is taken to be capital V, total current of the circuit is taken to be capital I, and total resistance in the circuit is considered or taken to be capital R. So, try to be familiar with these alphabetic representations of capital V, capital I, capital R. These are the total potential difference, total current, total resistance respectively. Then R1, R2, R3, I1, I2, I3, V1, V2, V3. These are the resistance, current and potential difference of first resistance, of second resistance and of third resistance separately and individually. Got it? Fine. So, I hope you have understood this particular concept of what are the total or the individual potential differences, currents and resistances. Fine. Now, let us take an activity. Students, let's have some fun with the help of this animated video where we will show resistances in series. For this, you will be requiring certain material. What all you will be requiring? Let us see. will be requiring the resistors, namely R1, R2 and R3 of 1 ohm, 2 ohm and 3 ohm respectively. Then we will be requiring connecting wires, will require a battery, will require plug key, will be requiring an ammeter to record the amount of current and a voltmeter for measuring potential difference. Now, let us come to the procedure as to how to proceed with this activity. We will take three resistors R1, R2 and R3 of resistances 1 ohm, 2 ohm and 3 ohm respectively and connect them in series with a battery, a plug key and an ammeter, and connect a voltmeter in parallel in between points P and S. You can see how exactly the setup has been made, right? Now, insert the key in the plug and record the current flowing in the circuit from the ammeter and potential difference from the voltmeter. Now, do one thing, disconnect ammeter from position X and reconnect it in series anywhere between the resistance R1, R2 and R3, and again note down the current in the ammeter. You observe that the current remains the same irrespective of the position where the ammeter is placed. Having recorded the potential difference from the voltmeter in between point P and S, connect it in between points P and Q. Now, when you do it, then do it with connecting it between Q and R and S and record the potential difference in each case. So, let the potential difference between the point P and S is V, P and Q is V1, Q and R V2, R and S is V3. Now, when you record the observations, you will note that V is equal to V1 plus V2 plus V3. So, from this activity, we concluded a lot many things. Number one, we concluded that the current in each of the resistances joined or connected in series, the amount of current remains the same. If you look at the table, you can see it is 2 amperes every time. But we also concluded that the potential difference across each resistor connected in series is different. We can see above, and importantly, the total potential difference represented by capital V is equal to the sum of all the individual potential differences V1, V2 and V3. If we add them up, the total sum is equal to the total potential difference. Clear? The total potential difference, of a circuit is equal to the sum of individual potential differences. It is equal to the sum of any individual potential differences of resistances connected in series. That means, if I am connecting the individual resistances, then the potential difference in each and individual resistances, the sum total of all is equal to the potential difference which is in totality in the circuit, provided they are connected in series. So, when I am taking a series combination, there are two very important things that I have noted down, that I am going to conclude once again here. In series, I have talked about first thing, that the total current and the current in the first resistance, current in the second resistance, current in the third resistance, they all are same when we are talking about resistances connected in series. And same in series, if I talk about potential difference, then the potential difference across the first, across the second, across the third, they may or may not be same, but their sum is equal to the total potential difference of series combination. This is quite important thing that we need to remember. Now, based on these two conclusions, now we are going to find a yet very important thing, and that important thing is the total resistance. The total resistance in series. Abhi, at the moment I'll be talking about in series. Fine. Let us take once again the same setup. This was the first resistance, this was the second resistance, this was the third resistance that I have taken earlier also. Connecting it with a cell or a battery, plug key, ammeter connected, plus minus arrows. These arrows are quite important to be represented. Fine. This we have taken to be the first resistance R1, the second resistance R2, third resistance R3. The current across this considered to be I1, this I2, this I3. The potential difference is considered to be V1, V2, V3. This was the total potential difference. This was from here we consider total current to be capital I. Fine. Now, we will be calculating what will be the total resistance. When we are talking about the resistance connected in series, then the total resistance is calculated by the formula R1 plus R2 plus R3 and so on. As many resistances you join in series, the total resistance will be equal to the sum total of all the individual resistances. Now, where do this thing come from? For that, we will be deriving this total resistance. And for this derivation, right, there are a few steps that I want you people to follow. What are the various steps? First of all, I will start with plus item. Plus item in V or I in series. Right. Now, what is this? I'll explain. Don't worry. Just have some patience. Fine. Then apply Ohm's law. That is V is equal to IR. V1 will be equal to I1 R1 and so on. V2 will be equal to I2 R2 and so on. This is what we are going to apply. Then use equal to item, that is equal to item, and substitute values. Not able to understand whatever I am writing, huh? Don't worry, just wait for another 2 minutes, you will get each and everything crystal clear. Then after doing this third step, take common. Take common, cancel it, and here is our answer. Now, mentioned or specified in a very raw form. Let us see exactly what we have said as to get what we exactly want. Fine. Remember these steps that I have mentioned? When I am talking about the derivation, what I have said was in series we had got two things. First, I was equal to I1 is equal to I2 is equal to I3, and second thing we related was V is equal to V1 plus V2 plus V3. So, whatever I have written in these steps we will take as a layman. According to me, this one is the plus item and this one is the is equal to item. Now you got it? So, I will start with plus item. Now, as per our conclusions above, we know that in series V is equal to V1 plus V2 plus V3 and so on, right. This is my first step. Now you have understood. Start with plus item in V or I, whatever it is. In series, it's V which is in plus item, right? So I'll start up with plus item. Now the second step I will do is I'll apply Ohm's law, that is V is equal to IR, V1 is equal to I1 R1 and so on. So instead of writing V, I may write out V is equal to, instead of V I can write IR because V is equal to IR. Rather than writing V1, I can write I1 R1 plus instead of V2, I can write I2 R2 and instead of V3, I can write I3 R3 and so on. Fine. This is my second step. Apply Ohm's law. Now, the third step was use equal to item. Now, in series, I can find here that the current is equal throughout. So, instead of I1, I can write I, instead of I2, I can write I, instead of I3, I can write I because they are all equal. So, this is my third step. IR, I will keep it as it is. This I1 R1 can be written as IR1 because I1 and I are same using this particular phenomena, plus I2 R2 can be written as IR2 plus I3 R3 can be written as IR3. Simple. This is my third step. Now, fourth step is take common. Let us write what we have just written over above. IR is equal to IR1 plus IR2 plus IR3. Among these, I can see that I can take I common. So, if I take I common, I will get R1 here plus I has been taken common, I will get R2 plus I has been taken common, I will get R3. So, take common, this I and this I is going to be cancelled out with each other and I am left with R is equal to R1 is equal to R2 plus R3 and this is our answer, right. So, this is the total resistance, that is what we are calculating in series. Now, try to remember all the steps that we have taken, just brush it up fastly. First of all, the first step was start up with the plus item and in series the plus item is V is equal to V1 plus V2 plus V3. We have got two resistances, I will take V1 plus V2. If I have taken three resistances, V1, V2, V3, maybe it's 4, maybe it's 5, maybe it's 6, I will place dot dot dot, as many you can take, right. Second step was apply Ohm's law. So, I will take V is equal to IR, V1 is equal to I1 into R1 plus V2 is equal to I2 into R2 plus V3 is equal to I3 into R3 and so on. Third, take the is equal to item. Is equal to was this, instead of this I2, I1, I3, I can simply take I and I. Then I will take I common. This I is going out to be cancelled out and I will get my requisite equation or formula, whatever you want to say. Got it? Fine. This is the total resistance calculated in series. This is the derivation, quite important. You get it many times in the examination. Fine, right? Now, the same we will do when we are talking about the second type of combinations. Fine. So, to conclude the series combinations, what we have seen in series combination, try to relate. First, the total resistance is equal to R1 plus R2 plus R3 and so on. When I talked about current, I is equal to I1 is equal to I2 is equal to I3 and so on, as many as resistance you can take. Third thing is V is equal to V1 plus V2 plus V3. These are the three conclusions that we need to remember when we are talking about series combinations. Clear to all? Sure? Good.